Good afternoon, students. Today we are going to discuss about the computation of net present value method. In this example, you can see that there are three possible projects given with their original investments along with the net cash inflow in the years. For example, if an investor invests in project A with 5,000 rupees, his cash inflows given are 2,500 for all the three consecutive years. If he invests in project B, 5,000 rupees, his net cash inflows are 1,000, 2,000 and 6,000. If he invests in project C, with original investment 5,000, the net cash inflows are 5,000, 1,500 and 1,500 respectively. Now here we have to compute the net present value for A, B and C at 10% discount rate.
आता
So we will be calculating the net present value for all the three projects and then concluding for our answer. Now before computing the net present value, you can see that the formula for computing the net present value is summation n equals 1 from 1 to n, that is capital N, and taking the value from 1 to capital N, Rn upon 1 plus R raised to n minus C. Now let us try to understand the notations. This small n indicates the number of years, small r is the rate of discount, Rn, capital Rn, is the net cash inflows for n here, and C is the original investment. Now we have been given the capital inflows for different years, which we have already seen here. You can see these capital inflows given to you. So for the first project, it's 2500 for all the three consecutive years. So let us first find the net present value for investment A. You see it's 2500 upon 1 plus R, which is the rate of discount, which we take it as 10%. So it becomes 1 plus 0.10 raised to n, which is 1 year. And then for the second year, okay, the substitution will be exactly the same, 2500 upon 1 plus 0.10, but it will be raised to 2 because it will be for the second year. For the third year, the same substitutions, only the number of year will be replaced by C, that is 3, I'm sorry, minus the original investment, which is 5,000. You can see in this table that the original investment is given 5,000.
it's 40.
Since the rate of discount is 10%, this becomes 1 plus 0.10, which is 1.1. So it's 1.2500 divided by 1.1 plus 2500 divided by 1.1 raised to 2 and plus 2500 divided by 1.1 raised to 3. Since we have only for the 3 years, we are confining our formulas only up to 3 years minus the original investment, which is 5,000. Now if I divide this 2500 by 1.1 using a normal calculator, you get it as 2273 plus, if you divide 2500 by 1.1 square, which will be 2066 plus. In the third year, you are dividing 2500 by 1.1 cube, okay, which gives you the answer 1878, which has from which 5000 will have to be subtracted as per the formula. The answer which we get while adding all the three years, we get 6217 minus 5000, which is rupees 1217. So we can see that the net present value of project A is 1217. Okay, the net present value considers the time value of money. Now let us calculate the net present value for project B in the same way. Now if we calculate the net present value for B, the formula will remain the same. Only the thing is that we will be considering the net cash inflows for the project B given to you in the table. You can see that for the B, the values are given as 1,000, 2,000 and 6,000. 5,000 being the original investment. Now let us come to the computation for project B, NPV for project B. You can see that now the first cash inflow will be 1,000 divided by 1.1, then plus 2,000 divided by 1.1 square as per the formula, plus 6,000, which is the net cash inflow for the third year, which has to be divided by 1.1 cube. And of course, we have to subtract minus 5,000. Now we can see that if you add these, if you divide this 1000 by 1.1, okay, 2000 by 1.1 square and 6000 by 1.1 cube and add them, you get the final answer as 7070. You can check it using calculators. Minus 5000. If I subtract this, I get the answer as 2050, which means that the net present value for project B is rupees 2070. Okay. Similarly, on the same lines, we will be computing the net present value for project C. Now, if you see for the project C, the net cash inflows as per the table, again have a look at the table. As per the table, it is 5,000, 1,500 and 1,500. 5,000 is the original investment. Now, let us again come back to the example for computation, and now we can see that net present value for C is computed here. 5,000 divided by 1.1, okay, plus 1,500 divided by 1.1 square plus 1,500 divided by 1.1 cube, as per the same formula which we are computing for NPV. As we have already seen the formula, we are using the same formula there. Okay, once again, let us have a look at the formula and then go ahead. See, this is the formula. NPV equals summation n takes the value from 1 to n, Rn upon 1 plus R raised to n minus C. So the same formula I am using it for computing NPAC also. And of course minus 5,000. Now you see the values if I get after dividing 5,000 by 1.1 is 4545. These are the approximated values I have taken. I have not taken the points. I have taken the next value. Okay, we have ignored the fractions here. Therefore 4545 plus 1240 plus 1217 and minus 5,000 of course. So finally we get it 6912 is the total addition minus 5,000, which we get it as 1912. Now think from the above computation, okay, we can conclude that among the all three NPVs which we have calculated, rupees 2070 happens to be the highest NPVs. Okay, and generally it is always preferable to invest in that project where the NPV is highest. And since we can see that the NPV 2070 for the project B is the highest one, the investor should invest in or prefer to invest in project B. That's all. Thank you for your time.